Okay, so one of the cool things about right triangles is that there are a couple of special ones that have these relationships with their sides, so that if you wanted to find a missing side, you actually don't have to do things like the Pythagorean theorem or trigonometry like sine, cosine, tangent. And there's only a couple of types out there in existence, really, that you're going to do that with or that you're going to learn about. So what we're going to talk about first is the 45, 45, 90 triangle, and what that's referring to are the angles. And whenever I drew this as best I could to scale, but with this triangle, we have an old rule that says, you know, if these angles are congruent, then the sides opposite those are congruent, and that's going to form a little isosceles right triangle. So these are always going to be congruent, these are always going to be congruent. And the reason that that's pretty cool is because if I did just give you a side, if I was like, okay, this is a random side, I'm going to call it S, then I know for sure that the other side is also going to be S, which is awesome. And what's further awesome is that I don't need SOHCAHTOA or anything else, because this side, the hypotenuse over here, it has a special relationship as well. And what it's going to be is the side times the square root of 2. Now, if you don't believe me, we could do a squared plus b squared equals c squared. And we could plug in the s for the a squared and the b squared. And when I do that, if I'm doing s squared plus s squared, that's really 2s squared. And I would then take the square root of both sides. So when I do that, I'd have the square root of 2s squared equals c. And that simplifies to the square root of 2 times s, or s times the square root of 2. So you could go through the Pythagorean theorem each and every time, but this relationship is always going to happen. Now, if I just did all that and you're like, what? Okay, just ignore it. That's fine. I just wanted to show you why it works. But now that you know it works, let's do a couple practice problems. So the power of this would be something like the following, where someone gives you a picture and they're like, hey, 45, 45, 90, and this is a 6. So if they tell you one side, you automatically know the others, because this is one of the legs, which means that the 6 is in the same spot as that s. So, I mean, s is 6, guys, so if this side is 6, then that means this side is also 6, and then it means that you can find your hypotenuse by just doing 6 times the square root of 2. So that's pretty cool stuff. You can also work backwards from a hypotenuse. So if somebody gave us the following problem, let's do one upside down here, and they were like, hey, 10 root 2. If they told us that, and maybe they label these or maybe they label those, we know that's 45, 45 because they're congruent. And now we know it's the same as this picture above. And so if that's happening, what you have to do is look at it and think, okay, what did they just give me? Well, they just gave me the hypotenuse of this picture. So what I can do is go up here and compare it to the hypotenuse of this picture. So if I compare those two, I can just make an equation from them and say, okay, well, this hypotenuse has to equal this hypotenuse. And by setting up an equation, I can now solve for s. Now, some of y'all can do this in your head. You can just see automatically, oh, s is 10. But if you can't see that, if you want to solve for s, you just divide both sides by the square root of 2. Okay? Whatever you do to one side, you do to the other. They're going to cancel out, and then you could see for yourself that s is 10. Then you could go fill in your picture. So not too terrible, right? So what's the hardest kind of problem you might see? All right, how about, I mean, this may or may not be the hardest, but I'll try to make it up. Oh, that's a terrible triangle. Hold on, let me try to make it look isosceles. There we go, that looks a little bit better. Okay, so 45, 45, 90, and what if they put a funky number here? Like maybe they put like 15, and you're trying to figure out what these legs are. So if you compare it to the one above, just like I did earlier, okay, what part of the picture do you have? Well, you have the hypotenuse, right? So the hypotenuse of this picture is supposed to equal the hypotenuse of what's above. So let me scroll above, and the hypotenuse up here is s root 2. So I'm going to set those equal to one another. Okay, so the first part is just like identifying the side and then making an equation, and now I need to figure out what s is. So just like before, how do I get s by itself? Well, I divide that number away from it, and if I do that to both sides, then I know that s is equal to 15 over root 2. Now that's technically your answer, but most teachers don't like this answer because it's ugly, and in math it's ugly to have a radical on the bottom, so we prefer that you rationalize. Now rationalizing is that deal where you take the radical on the bottom and you multiply by it over itself, top times top, bottom times bottom, and this would be your answer. So you'd put a 15 root 2 over 2, 15 root 2 over 2, and even though it's ugly, people, this is your answer. You don't want to type this in a calculator. We don't want your decimals. You don't have to do Pythagorean theorem. You don't have to do SOHCAHTOA. So that is the power of these, is just memorizing a little relationship and then being able to set up an equation and solve. So there's also a 30, 60, 90 triangle, so make sure that you watch that video to see those relationships. Thanks.